Thank you very much for coming to this talk. This talk is really a little bit about everything. Primarily, my goal is to show you how you can use NoSQL in Java EE based systems. More precisely, Java EE 5, Java EE 6, and Java EE 7 based systems. My name is Reza Rahman. If you're not familiar with who I am officially a Java EE Glassfish evangelist. I'm relatively new to Oracle. I've joined Oracle, I guess, since last September or so. Before that, I had been an independent consultant for a long time. I've been working with Java EE, specifically the JCP, for a very long time. And I wrote a book called EJB3 in Action from Manning Publications. And also, I wrote the EJB container for Resin 4. Anyway, so one of the things that you should know about this talk is that this talk is not Oracle sanctioned. So it's not like my goal is to tell you what Oracle thinks about anything. This talk is really about my own observations in how to use NoSQL in Java EE based systems. So our agenda is roughly broken down into 3 parts. I'll be talking a little bit about the NoSQL landscape, first and foremost, just to get an idea of what exactly is NoSQL and why would you consider it, and what are some of the primary characteristics of NoSQL solutions. And the other 2 parts are really about how you can use NoSQL in Java EE based systems, primarily through 2 different APIs. First and foremost, we'll be talking about how you may be able to utilize JPA to access NoSQL databases. For the third and last part of the talk, I'll also be talking about how you can use NoSQL directly via a solution like a pure dependency injection solution like CDI. Okay, so let's talk a little bit about what NoSQL is really about. And surprisingly, this is probably the hardest and most opinionated slide in all of my slide decks, because it's difficult to define really what NoSQL is. As the no part of the NoSQL part indicates, really it's easier to define NoSQL by starting with what it is not. If you were to make a broad generalization, what NoSQL databases really are any sort of data stores, meaning any mechanism, any software that allows you to store data in a persistent fashion that does not conform to the RDMS, the Relational Database Management System paradigms. That's a very broad statement. Specifically, what is it that means? What this means is, in most NoSQL databases, you will have NoSQL queries, okay? There is no, these are not SQL conformant databases, and hence SQL doesn't make sense in them. Generally, a lot of these databases, they will not come with any kind of query capabilities at all, in the sense that we are familiar with, rich queries that would allow you to specify very specific constraints or very flexible constraints. Usually these are schema-less, and that's again a big word, but it's difficult to understand what specifically that means. So in relational databases, you know specifically how your data is structured and what the relationships are between them. So there's predefined tables that say, okay, this is how this bit of data looks like, and it's composed of these columns, and each of these columns have these data types. Generally, in NoSQL systems, there is no such structure. It really is all about kind of broad blank slates of space that you can fill in whatever it is that you like. As a result, because in order to really enforce things like referential integrity, namely this particular data is related to this data and it cannot be deleted until this data is deleted as well, or when you make a change here, this particular change should propagate into these other data structures. These concepts also do not exist in NoSQL databases, by virtue of the fact that in order to enforce those rules, you need to know how your data looks like first and foremost. Otherwise, how would you possibly enforce those rules? So there is no sense of referential integrity of any kind. Again, it's really sort of your raw data, and whatever you would like to store in that space, if you will. And henceforth, you also have no capability of joins. Now, what do I mean by joins? Again, in a traditional RDBMS sense, a join means, in a given individual query, you want to, at runtime, kind of coagulate two different bits of data, right? So you're joining employees with departments and the like. There is no such built-in mechanism in NoSQL databases. So the question that you really should ask yourself is, why would you then want to use a data store whose very definition is the lack of features, right? So it lacks these features, and that's the definition of it. Why, from a relational world, if you will, and more than likely all of you are relational database developers, would you even consider, such a thing? And the answer goes back to, all of the things that you usually, as enterprise developers and or enterprise architects, we deal with. So the primary problem with databases is the fact that databases work very hard in order to enforce things like transactions, data consistency, so asset properties, right? All of us are probably at least fairly familiar with what asset is. So it's atomicity, consistency, isolation, and durability. What that means is, atomicity means if you are making multiple units of work, if you have multiple actions in a single unit of work, that unit of work should fail or succeed as a unit, right? Similarly, consistency means, when you make a change to your data store should automatically enforce things like referential integrity, triggers, and the like. Isolation means essentially concurrency control, right? So when you are making a particular piece of data, you will be making that data change as though you were the only person on the database at that given point in time. So if there is parallel requests to a given piece of data, that somehow the database ought to be able to make those changes in a way that it appears sequential to you, right? So there is no concurrency conflicts per se. And durability simply means that when you make a change, you can be confident that that change has taken place into the database, and it has propagated, that change has propagated in real time to all of the instances that comprise your data store. Now, in order to facilitate these characteristics, these don't come cheap, right? And there's complex algorithms and complex bits of software that do these things for you. And the basic problem with relational databases are that you cannot scale these characteristics. So you can guarantee asset properties very simply in one machine. And you can scale up do vertical scalability of that machine by adding more CPU power, adding more memory, and the like. You can have more powerful machines. And you can very easily guarantee asset properties. We have done that for the 30-some years now on a single machine. You can extend that to more than one machine, 2 machines, 3 machines, 4 machines. Not a big deal. Like, there's even if you were to use an Oracle rack or Oracle Golden Gate, you can perhaps scale that out to as many as 10 machines. And that's quite a remarkable feat to be able to do that, to be able to give you those consistency guarantees, those asset property guarantees across a 10 machine cluster. The problem really comes in when you go beyond that cluster. So can we really guarantee asset properties on a 100 machine cluster? Not an easy thing to do, virtually impossible, right? No, somebody told you that's possible, they're lying, right? So those are the cases where you need, in order, if you have that type of data, you're talking about like terabytes of data, there's no way you can store that data in a relational database and guarantee asset properties. And hence, what you need to do is you need to give something up. So what do these NoSQL databases give up to? In order to do that, they give up the asset properties. Right? Instead, what they give you is called base. Okay, and what this means is basically available and eventually soft state, and eventually consistent. So you're giving up those asset property to say, okay, you know what? I have this very large set of data that I need to store somehow. So I got to store it, and I have to give up some things, and I'm going to give up these characteristics. And that's really what NoSQL databases are really about. That's their primary motivator. The other motivator, of course, is that in order to apply things like Oracle RAC or Oracle Golden Gate, these are not commodity solutions, right? I mean, these are relatively complex bits of software that come with a price tag. Whereas most NoSQL databases, because of the fact that they're giving up on some quality as a service, are commodity are software. You're probably not paying a whole lot of money in order to have a 100 machine MongoDB cluster or what have you. So let's talk a little bit about what base means for a second. So basically available means that if you have a 100 machine cluster, you are guaranteed that at least you'll have some measure of availability. So 10 of those machines could have failed, and your network will basically still be available. You won't have all of your data all the time. You're not guaranteed that, but at least you'll have access to some of the data. Similarly, soft state means that you're giving up on the value of consistency. You're giving up on the idea that when you make a change, all of that change will, in real time, will propagate across your cluster. Again, not a scalable thing that's achievable across a very large cluster. And finally, eventually consistent. So rest assured, even though you're not getting real-time consistency, most NoSQL databases will make an effort such that your particular change will eventually make it across the cluster. Okay. So when we say these things, hopefully by now it's relatively clear what NoSQL databases are. So the reality is this: although the NoSQL database vendors will tell you, you absolutely need these things, and every system should have NoSQL databases. This is not the truth, okay, either. And the reason it's not the truth is because in most systems, a single machine relational database will go a long way. Okay, a single machine database like an Oracle database can handle multiple millions in rows of data without any problems. Okay, so if you really are going beyond that scale and you're really talking about global scale data, the kind of data that the Amazons and the eBays of the world see, that's when you really should be thinking about NoSQL databases. So so that's again a broad statement. What should you be thinking about as a developer? It's really quite simple. If you are if you are having real trouble with your relational database, that you've made reasonable optimizations and you're running into issues of you're running out of memory consistently, you're running out of CPU consistently, that is when you should start thinking about, okay, can I, in this case, apply a NoSQL solution? Can I give up those asset properties? And if those two things are true, that's the only case where you would think about NoSQL databases. NoSQL databases today are extremely divergent. They really are a snowflake. Each of them have extremely different characteristics and different ways that they implement things. However, as I guess some measure of maturity, you will see some taxonomies of these databases. You can have some kind of categorization of them. So namely, you have key value stores. So these look like essentially hash maps in Java. You have document databases that are blobs. You can, if you're coming from a relational world, this is just blobs, databases consisting of blobs. Usually these are stored in some kind of structured data format like JSON or BSON. There's graph databases, and these take the idea of relationships to an extreme. Okay, so by default, these are really big linked lists with the trees and forests linking data to each other. And finally, you have columnar databases that kind of look like poor man's relational database. So the players in this market today are things like MongoDB, Cassandra, Google Bigtable, CouchDB, HBase, Neo4j, and Oracle NoSQL. So as you can imagine, if there's an Oracle NoSQL, there is something to it, right? Now, Oracle is not the kind of company that would have invested in a NoSQL database if there wasn't at least a valid use case for some applications. So one of my favorite things to do when I look at these new kind of technologies is I pull up Indeed.com. And the reason I do it is of all the job sites, Indeed.com has this very neat feature of being able to graph trends of keywords. So this is what I did. I plugged in a bunch of the sort of buzzwordy NoSQL database, and I saw what the trends are. And the trends looks like this. Okay, so clearly there's a few NoSQL databases that are very niche solutions, and their growth rate is relatively flatlined over a period of time. So these databases probably are not very generally applicable. Okay, you do see a rapid growth rate on some databases, though, right? So, for example, MongoDB, Cassandra, and HBase clearly are experiencing pretty explosive growth, right, year over year. However, what you should also note is the vertical axis of this graph. Okay, so although this graph looks impressive, if you look at it visually, in reality, there's only 0.08% of jobs posted on Indeed.com that mention MongoDB. Okay, so we're really talking about a niche market here. Okay, so let's talk a little bit about the case for JPA. So as you can imagine, so these are the cases. So first and foremost, let me tell you this. JPA is not designed for NoSQL databases, okay? And JPA in its current form is not a good fit for NoSQL databases. The reason being, JPA was designed for ORM, right? Object relational mapping. It's designed for relational databases in mind. However, if you really think about it, the problem of mapping persistent solutions to Java objects is quite generic, right? So it's not too difficult, as you will see, to conceive of a solution that utilizes parts of JPA to access to create a NoSQL to create a facade over NoSQL solutions. And as a matter of fact, as I'll show you, in the JavaEE ecosystem, there's rapidly emerging quite a few solutions that do exactly that and do it relatively effectively. So question is, what is the use case here? You know, why is it that you should consider these solutions? First and foremost, you know, if you are evaluating between multiple of these NoSQL solutions, the generic case, if you're not using any kind of facade, is that you gotta pick up the documentation for this NoSQL database and read through it and try to figure out, you know, what all these features are. And as it turns out, the basic features are not very different from each other at all, right? So it's you're doing the basic same thing. You know, you have some data, you're mapping it to the data store, and you have to do some CRUD operations, create, read, update operations. So what JPA allows you to do is, if you already know JPA, then you can use these databases without having to necessarily learn a new API, right? Because you already know ORM probably, you already know JPA probably. The other nice thing is, it's very nice to use this particular solution in the case where you may change your mind later, right? So, you know, you can start with, like, Cassandra, and at some point you find out, Cassandra is not a good solution for me. I need to switch to something else. If you're not using something like a JPA-based facade, or using something that's very specific to that particular database, you have some rewriting to do. You have some refactoring to do, potentially in a system that you've already deployed to production, right? With a JPA-based facade, making that switch becomes very easy, because you're really writing to the JPA you're really writing to the JPA API, and then hopefully you can simply make some configuration changes to change the data source from one to the other. And also, polyglot persistence is very difficult unless you're using something like JPA. So what do I mean by polyglot persistence? By polyglot persistence, what I mean is you have mixed mode data, right? So you have some data that is stored in relational databases. You may have some data that's stored in Cassandra or a name value paired database, because that's the right fit for that particular data. And you may have some data that's stored in a document database like MongoDB, right? So if you are using something like JPA, most of the JPA-based solutions that I'll be talking to you today will make it possible such that you can create one persistence unit and simply apply metadata to your POJOs to say, oh, this part of my persistence layer goes to the relational database. This part goes to Cassandra. This part goes to MongoDB. And you still have just one application, just one domain model, and one API set, as opposed to having multiple API sets. And generally, these NoSQL APIs, in relatively speaking to JPA, are relatively low level and relatively more verbose. Okay. All right. So One of the solutions that I'll talk to you today, and I'll demo it for you, is EclipseLink NoSQL. So what this is, it's essentially leveraging the non-relational database support that has been there in EclipseLink for a little while, and applying it to NoSQL databases. And the only thing you really need to do is, in order for to identify as an entity as being stored in a NoSQL database, you simply need to annotate it with @NoSQL, and we'll see examples of that in just a second. The basic idea, the approach of EclipseLink NoSQL is support what's there. Okay, so if a particular data source supports querying, support it, right? If it doesn't support it, can't support queries. Sorry, you're basically stuck with basic CRUD functionality, and so on and so forth, right? But that's the basic philosophy of EclipseLink NoSQL. Okay. Initially, there is support only for MongoDB and Oracle NoSQL, but there's plans of supporting other databases like Cassandra, HBase, and MongoDB, and maybe this is something you could get involved in if this interests you, and contribute perhaps a module for these NoSQL databases. Very nice thing about EclipseLink NoSQL is they allow just what I described earlier, mixing and matching relational and non-relational databases in a single composite unit. Okay, so let's see how applying JPA to NoSQL looks like. So as you know, if you've worked with JPA and mappings generally fall into two different types of annotations. One is annotations that allow you to describe your domain model, right? So things like entities, embeddables, element collection, one-to-many, many-to-many, and so on. These have nothing to do with, per se, with relational databases. They're simply describing relationships between objects in your domain model. And as you can imagine, generally these concepts apply to NoSQL quite well, because at the end of the day, it's not like NoSQL just appears out of thin air, right? Ultimately, you will be designing some kind of an Java-based object model, even in these cases. Some concepts apply to some databases as well, like things like JPQL and named native queries apply to some databases that support querying, and they don't apply very well to some databases. The pure relational databases don't apply well at all. Okay, so things like table, column, collection table, sequence, and the like don't really apply in the NoSQL world because it's not a relational model. These annotations don't make any sense in that world. Okay. In terms of querying, you have three different types of querying in JPA, as you know. Basic finders. Generally, these are supported by NoSQL databases. JPQL, and that's a portable language defined by the specification. And some parts, and JPQL, for the most part, for databases that support querying, fits relatively well, because all the persistence engine really does is it takes your JPQL statement and translates it to its native format. For example, this fits rather well in MongoDB, for example, but not so well in Oracle NoSQL that doesn't really have a query API per se. And of course, native queries fit rather well. Dynamic or static named queries will fit wherever JPQL fits. Okay, so here's an example of how a MongoDB mapping might look like. Okay, so not terribly different from JPA at all. It's an entity. We say it's a NoSQL entity, and the data format type is mapped. That's what makes sense in a document database like MongoDB. You have IDs. You have the IDs can be generated, and they generally are for MongoDB. The at field is the corresponding data annotation to at column, right? So you don't really have columns in document data sources, but databases, but you have fields. Okay, and in MongoDB, IDs are a special type of field. They're a sort of a magic value field named @_ID. So every single object that you store in MongoDB automatically gets this little underscore ID field. That really is a UUID. It's a globally unique identifier. Other than that, things like strings and ints and longs, obviously can fit very well into a MongoDB field. But notice, you can also have interesting things like relationships, entity relationships. So you might want to ask, okay, so how does something like, for example, a MongoDB support these relationships? And as a matter of fact, they don't, right? I mean, I already told you, these are not databases that support joins relatively, or joins natively. So what this is where EclipseLink helps you out. Okay, so what EclipseLink does under the hood is it takes these generated underscore IDs and simply dumps it out into a field. Okay, so that's how relationships are established. So it says if entity X is related to entity Y, then let me take entity Y's little ID and stick it in a field for entity X. Okay, that's, as a matter of fact, exactly what you would be doing. Sort of manually creating your own relationships as opposed to the ones that are defined and managed by the database. You can also have things like element collections and embeddable objects, and those you really just translate into embeddable and nested objects inside of something like MongoDB. Okay, JPQL looks something like this. You can support total cost greater than 1,000, and that will translate into MongoDB quite well. You can have descriptions like pinball. You can have simple joins, and again, what here's where EclipseLink is helping you out by resolving these relationships under the hood and making this happen for you. And of course, you can have MongoDB native queries too. So you can have, say, things like find one by this ID and order class and the like. Okay, so let me now do a demo. In the demo, I'll show you how EclipseLink works with a pretty simple data set using MongoDB as the backend. You can get the code, by the way, from this URL. I'll make, I don't know if I'm going to have time for this talk either. This is a very long talk an hour-long talk that I need to fit into a 50-minute. Pardon? Yes, from Glasgow. Yes, that's right. But you can get that, and that's a Maven project. You can download and install it yourself. Okay, so let me go into the demo real quick. I'll go ahead and start MongoDB. MongoDB. Okay. And here's my MongoDB. Here's my project. JPA project. Here's the source packages. The address is simply an embeddable, right? Again, that NoSQL thing, and the rest of it is very simple. It's just setters and getters for a few fields. Okay. Similarly, customer is very simple. It's an entity mapped by the NoSQL annotation and that magic at ID field. And other than that, it's just got a name. Order is another entity. Okay, and then again that ID field and some descriptions. The order lines are an embeddable object in here, order lines. And other than that, there's a total cost and a version. There's some other embedded objects that I've created in terms of the address and the like. And there's a many-to-one relationship with customer as well. So order line is similarly very simple. It's an embeddable that has a line number and an address and a cost. I'll show you how the persistence.xml looks like. Okay, source. And it looks like pretty much like any other persistence.xml with a couple of exceptions. So in this case, we're specifying the EclipseLink.target database, and we're saying that we want to connect to MongoDB, okay, by saying mongo.mongo platform. And we have a connection specification that's describing what the connection properties look like. And I'm simply specifying mongo.mongo connection spec. And that's connecting to the default host and default port. And the default host is localhost. The default port is 270717, which is what MongoDB is listing on. Hopefully I have the Mongo. Yep. There, 270717. Okay, and you can specify that yourself if you so wish. I have specified a Mongo database, and you don't have to do that. It can default out to its default value. And in the test package, I simply have a very simple unit test here. Okay, so I'm cleaning up the database, doing some minor setup there. And the test persist is simply, creating a customer, setting a name, and persisting it. Very, very normal, usual JPA code. Again, creating an order, creating an address, setting the address, and simply again doing a persist. Nothing unusual at all. This looks very much like vanilla SQL or vanilla JPA queries. Similarly, a finder is simply doing a find by OID. A test query, I have a couple of different JPQL queries. The 3 JPQL queries that I showed you. A simple total cost greater than 1,000. A description matching a regular expression like statement, and I also have the join query that kind of is doing a join with another database that's again EclipseLink is doing for you. I also have a native query with MongoDB as well. Okay, I'm doing an update here with a finder and also doing a find and a remove, etc. So let's go ahead and run this guy. And it runs, right? So pretty amazing if you think about it. We just did a bunch of operations against MongoDB. Don't have to know anything about MongoDB whatsoever. You're just writing plain old JPA code. Okay. All right, let's go back into my presentation. So EclipseLink NoSQL is not the only, by far not the only solution in this space. Hibernate OGM does a very similar thing. So it takes a Hibernate code base and applies to NoSQL. They support MongoDB and InfiniSpan at this point in time. Hibernate OGM has the opposite philosophy of what EclipseLink does. So what it tries to do is that it tries to apply as much of JPA as possible. It even goes to the extent where databases, NoSQL databases that don't support queries, it creates its own native index and indexing tables, relational tables itself in Lucene, and that's how it allows you to do queries even with something like a simple name value pair database. There's also Data Nucleus. It's a very interesting piece of software that applies that uses JPA. If you've used Google App Engine, it's actually the Google App Engine persistence engine for it. That's what they do persistence with. And it supports actually the widest variety of databases of these family of solutions. So it supports MongoDB, HBase, and Neo4j. There's also Kundera, and that supports, again, that's another solution that applies JPA to NoSQL databases. And that has Cassandra, MongoDB, and HBase. There's EasyCassandra, sort of a Java.NET project that's Cassandra only, again supporting JPA. PlayORM is very interesting, as well as Morphia. And both of these, actually, what they do is they have annotations, and the annotations, actually, if you look at it, is not really very different from JPA annotations. They're just some slight variations. So they're also proving out the concept that this works. You can actually do this. Okay, I also have links to all of these things, so feel free to take a look at those, whenever you so please, in the resources section. So let's talk about CDI in a second. So CDI, I won't talk about a great deal of it. It's the standard API for dependency injection included in Java EE 6 and EE 7 onward. It basically standardizes the ideas in Seam2, Juice, and Spring, and the like. These are the basic annotations for it. As you can imagine, @inject, @qualifier, named, stereotype. Very, very usual stuff. Some scoping management annotations. There's lightweight events. There's interceptors and decorators. And there's a portable extensions API that is very interesting. So what this allows you to do is allows you to create third-party plugins on top of CDI. So the question is when should you think of CDI in terms of these APIs? What I should point out is that while these are interesting solutions and applying JPA to the problem of NoSQL, most of these solutions will, if you read about them, acknowledge the problem that because of the fact that the NoSQL market is so divergent, it may not be possible at all or even practical to expect that every single NoSQL solution will be supported in this way. It may very well be the case, but it's unlikely and it's not going to happen very quickly, right? When you're using JPA to use these NoSQL databases, what you lose out and will lose out on is the very, very advanced, very, very highly specialized features that each of these data stores have, right? The JPA-based solution is sort of good enough to cover the 80% use case, but there's still that 20% that is laying on this very, very advanced features. There's of course, due to the fact that this is such a dynamic field, there's always going to be some NoSQL solutions that there aren't JPA-based facades for. And as a matter of fact, it also may be the case that you already know some of these NoSQL APIs, so it makes sense for you to continue using them as a matter of personal preference. Now, the nice thing about these JPA, these NoSQL implementations are that the APIs that these guys are designing are relatively new APIs, right? So these are APIs not designed in 1997 or 2005. They're being designed in 2012, right? So generally, these are not terrible APIs, and you can very easily just use those native query APIs, and at least you will be productive with them, right? You'll have the other problems that we mentioned about before, but you'll be productive with them for the most part. And because they're all Java-based, because they're all POJO-based, you can easily integrate them via CDI as well. Okay, so let me show you an example of what that looks like. I think an example in this case really says a lot more than just slides. Okay, so here's so what I did was I took my JPA example and I ported it over to MongoDB, okay? So now I'm using the MongoDB Java driver directly from CDI. So this is how my code looks like. You've seen the code before, so it's kind of easy to do a before and after comparison, if you will. Those are my domain objects that I created before. You'll notice that in this case they will extend basic DB object, and under the hood, really what objects in MongoDB are stored are really hash maps, right? You're storing sort of these objects that have a bunch of keys and values, and the like. Okay. So if you do, so what I decided to do is the basic DB object has these methods called getString, getInt, getLong that gives you a little bit of type safety, but you're really doing a lookup of the field names. So in order to give it a little bit more of an object-oriented feel, what I did was I created simple facades over them, right? So getStreet is really a call to getStreet with name of street, getString with street, and setStreet is similarly a setter. Same thing for city, same thing for state, same thing for zip. So not too bad, right? Not as good as JPA, but not horrible, right? Similarly, same thing for customer here. Customers collection. Let's talk about that in just a second. And order is again this very, very similar concept, right? So you have a bunch of setters and getters that are under the hood, just manipulating MongoDB objects, right? Same thing for order line, etc. So now let's take a look at my unit test. Okay, so here's how my unit test looks like. All right, so let's not take a look at this part of the code quite yet. I'll go over that in just a second. I'm using Archillion here, so I'm creating a micro deployment. Let you take a look at this. It's not that important for my particular part of the talk. The test persist is again very similar. So I'm taking creating a customer, setting the customer name, and doing customers.insert. That's how you do an insert in MongoDB. Okay, you take what's called a collection, and on that collection gives you CRUD APIs. So I'm inserting a customer into the customers collection. Similarly, in order to create an order, in this case, because there's no real concept of relationships, you need to manually reference IDs, right? So when in the order, I have a set customer ID field, and then I set it to the customer that this order is related to. Okay. But other than this, I just do the same old thing, and I simply do orders.insert. And same thing here. There's a simple finder, right? So I do orders, which is again a MongoDB collection. I do a find one with the object ID of order ID, right? I have capabilities of doing queries. So I can do a total cost field, and I can put in a regex value of greater than 1,000, equivalent of what I was doing in JPA. I can do regex type regex equivalents of SQL-like, right? So I can do a pattern.compile of tilde pinball against the description field. I can do some basic joins, by saying, order lines.description, give me the description with the name, right? But I can do it against the orders query. Similarly, I can do updates, and I can do removes. Okay, so let me run this query a little bit, and then I'll ask you a simple question after I run my test. Okay, so let me test this guy out. Remember, MongoDB is running in the background. And it's done, right? Not a big surprise there. How many people think, so the question you should ask yourself is, take a look at this code then. And at the very top of my test, I'm injecting two different things, right? The DB collection, the customers collection and the DB collection, right? I'm saying @inject customer collection and inject a DB collection for me, and I'm working on those DB collections in my unit test. So how many people think this is all there is to the MongoDB Java driver? Do you really expect this to be quite this simple? No, not really. There's a little bit of CDI magic that I've applied, and the reason I've applied it is because I want my unit tests to look as just as simple as this, right? I don't want to be doing connection handling. I don't want to establish the database, do database cleanup and the like. All of that should be done for me, right? And all I really should be doing in my business case, in my DIO or in my unit test, is simply manipulate the DB collections, and everything else should be taken care of under the hood. So in this case, the person that is the thing that is doing the heavy lifting for me is CDI. Okay, so I have a CDI factory here that happens to be application scope, so it's scoped to the application. I'm under the hood, and I have a MongoDB client, and this is the client API to connect to Mongo. On post construct, which is when my application starts up, what I do is I set up some logging, right? So you see some system.set properties and MongoDB.getLogger and all that stuff. I create a Mongo client, okay, and the Mongo client in this case is a new statement without any parameters, is because I'm using the default database and the default port and the like. If you so wish, you can specify a Mongo client config object, right, in here, and that's nothing but a set of properties. It's a, you set up whatever database you're connecting to, and the Mongo client constructor there takes that as an argument. But all I'm really doing here is that I'm constructing that Mongo client object and saving it off to my in my instance variable, and this connection is basically alive for the duration of my application by virtue of the fact that my factory is application scoped. And then what you can do is you can use a producer annotation to produce the things that I'm injecting into my unit test, right? So you're saying add produces customer collection, which is just a CDI qualifier. So if I click on this guy, you'll see that it's just a add qualifier and an annotation, a custom annotation that's uniquely identifying this particular DB collection object, right? And inside of this producer, all I'm doing is I'm getting the getting the underlying DB from the Mongo client, right? And from that DB, I'm getting a specific named collection named customers. So this is making, you know, all of that string manipulation is done in one place, and everything else is type safe, right? So everything else that you're injecting these collections to are all type safe. Similarly, for orders collection, I have similar code to do that. And finally, on the pre-destroy, which is when the application is going to shut down, I'm going to automatically do a clean database, right? In this case, I want to do that. It's handy for my demo. I go ahead and clean up the database. I say Mongo client.drop database, and I close the connection. Okay, so again, you know, you're getting rid of all of that boilerplate from your application code into a well-defined space in a factory object. Okay. All right, so let's go back to my presentation here. All right, so summary. In summary, again, NoSQL market is growing very fast, but it's still pretty immature. Some parts of JPA apply very well to NoSQL, and there's a lot of initiatives to do that, including one from Oracle, namely EclipseLink NoSQL. You should definitely get involved if this is an area that interests you. You should at least try these solutions out, and if it so interests you, you know, you can even get involved in some of these initiatives like EclipseLink NoSQL. You know, they are currently looking for committers, and perhaps you can contribute a module to support currently unsupported NoSQL database. And if you don't really want to use JPA, that's still fine. You can still use most native NoSQL APIs quite well with CDI. And the other thing that you should think about is, you know, sort of a to-do for you is whether you think any of this should be standardized, okay? Especially as of Java EE 8. So we're currently thinking about these things as well, and we would definitely like to hear from you to see what you would like us to do. Somehow I'll make these slides available. I'm not sure quite how yet. I think they already have those slides, and they should make them available to you via the conference. If you don't have it, just send me an email. I'll email the slide deck to you. But basically everything that I mentioned in the presentation, including all of the solutions, are in the resources section. Do feel free to take a look at them. Okay, I have a couple of minutes for Q&A, and then I'm done for this talk. So any questions? Yes, sir. I'm sorry? Transaction support. Majority of NoSQL solutions will not have them. So you're asking if JPA helps you out in that way? No, it doesn't. No. Yes, so you can. That's a good use case for the JPA-based facades. But what you need to be aware of is the transactions don't make any sense whatsoever in NoSQL world. Yeah. No, there won't be any exception. It'll just be ignored. Yeah, you can use it, but you know. All right. Any other questions? Yes, sir. Yes, you can.
Another question: is there any help from this framework to move from SQL to SQL database?
Yes. Yeah, of course. Just remove the NoSQL.
I didn't see anything that can help to move from NoSQL to SQL.
So let's suppose that you started with, you're using the JPA-based facade in
MongoDB.
EclipseLink from MongoDB, right?
Yeah,
So if you're using the polyglot persistence and you want to move from one paradigm to the other, it's as simple as just removing the @NoSQL annotation. That's it. And then suddenly in your persistence unit, everything will go to the relational database. So it's very fluid in that sense. Okay. Yes, sir.
Which Glassfish server version is shipped with the EclipseLink 2.4, I think?
2.4. Actually, I believe 3.1.12 ships with that. Glassfish 4 definitely ships with that.
Is this already in production?
Pardon?
Is this version of EclipseLink in
yes,
production?
Yes, it's released, of course. It's not beta or anything. It's released.
And packaged with Glassfish.
Packaged with Glassfish, or you can just get EclipseLink by itself and install it wherever you would like, Tomcat or JBoss or what have you.
Thank you.
Mm-hmm.
May I ask a question about is this any big company have in production such solution about JPA and NoSQL? And you mentioned about that we can have some impact on this process, choosing in G8 which NoSQL database will be included, and where we can find this talk.
So second part of the question I didn't quite get. The first part of the question is I don't know.
Okay.
Okay.
Second part of the question is Oracle starts some talk about which NoSQL databases should be included in next release, and where this talk can be found by us. Where we can find this talk.
So the resources section will have the documentation to each of these solutions. I still don't quite follow what you're saying. Are you talking about Oracle NoSQL in particular? Okay, Oracle NoSQL, I think there's not that much information out about it yet. There's just a white paper, and I think they have a little website on the Oracle pages somewhere. Maybe I don't know if I even have a resource for that. But send me an email, and then I'll dig it up for you. Okay.
Sorry guys, we have no time, so this is it.
All right, very good. Thank you.